All right, number 7 to 12. This is the Geometry Common Core, June 2017 regions. So number 7 says, which figure has exactly 4 lines of reflection that map the figure onto itself? So this is another one of those questions where you just want to work through each of the choices until you get to the correct answer. So if we look at a square, how many lines of reflection can I draw that will map the square onto itself? Well, I can draw one line of reflection like this, right? And that would mean that if I reflect this square across this line, it will map onto itself. I will get the same exact figure. So I can draw a line of reflection like that. I can draw another one like that. That's 2 lines of reflection, right? Then this would map here, this would map here, and it would map onto itself. So that's 2 so far. I can draw another one like this. That's 3 lines of reflection so far. And then the other one I can draw, can right through here. And then it would map onto itself. So that's a total of 4 lines of reflection, exactly 4 lines of reflection that I can draw. So the answer to number 7 is choice 1, the square. If you found the right answer, no need to go on. Can you draw any more lines of reflection that would get this to map? That would get the square to map onto itself? I don't think so. So this is the answer. Move on. Number 8, you can see that I already went ahead and I labeled some of the information that was given to me. It says that BC is 12, but I labeled it CE is 6, EB is 6. The reason I did that is because here in this sentence it says that chord DF bisects chord BC. So that means BC is being cut in half. E is a midpoint of BC. So that's how I got the 6 and 6 here. Then here it says FE is 5 more than DE. So what I did is I made DE X, and since FE is 5 more, I made FE X plus 5. All right? So now, to solve for X, you'll remember this theorem from your class. I hope you remember that A times B equals C times D. And that's what we're going to do here. We're going to go ahead and do X times X plus 5 equals 6 times 6, which is 36. So we will get X squared plus 5X equals 36. Subtract 36 on both sides because we now have a quadratic equation. This will cancel out. We get X squared plus 5X minus 36 equals 0. Now we factor this. So we're going to get X plus 9 and then X minus 4. 9 times negative 4 is negative 36, and then 9 subtract 4 is 5. So we solve this. I'm running out of room there. So what I'll do is I'll just write the answer here. You're going to get X equals negative 9 and X equals 4. We're going to reject this one. So X equals 4 is the value of X. So DE is 4 and FE is 9. So the answer is option 2. FE is 9. Number 9, Kelly is completing a proof based on the figure below. She was given that angle A is congruent to angle EDF. Let me go ahead and label that. Angle A is congruent to angle EDF. EDF, so those two are congruent. And she's already proven that AB is congruent to DE. Okay, so AB is congruent to DE. Which pair of corresponding parts and triangle congruency method would not prove triangle ABC is congruent to triangle DEF? All right, so this is one of those questions. Again, you have to work through each of the choices and eliminate the incorrect answers. So the first one says AC congruent to DF. So that's telling you this segment would be congruent to this segment. Yeah, that works. That will get us side angle side congruent to side angle side. So sorry about that. So that works. I'm going to just go ahead and erase that so I can work the next choice. So the next one says that BC is congruent to EF. Let's see. BC is congruent to EF, and it's saying that would be side angle side. Well, that's actually not side angle side. So this is not going to prove the answer. So the answer is option 2. Now, how do I know that's not side angle side? Remember, in side angle side, you have a side, an angle, and a side congruent to a side, an angle, and a side of another triangle. But the important thing is that the angle must be included. The angle must be in between those two congruent sides. And that's not the case here. This angle is not in between. So the answer is option 2. Okay, number 10 says, in the diagram below, DE divides AB and AC proportionally. Angle C is 26 degrees, angle A is 82 degrees, and DF bisects angle BDE. The measure of angle DFB is, there's a lot of stuff going on here. Now let's start. I like to always start with just the easiest stuff that pops out at me. So I'll tell you what pops out to me. Let me just zoom in here a little bit. The first thing that pops out to me is this DF bisects angle BDE. That tells me that the angle BDE is being bisected by DF, which forms two congruent angles. So this angle here and this angle here, they are equal to each other. That's important. The other thing that pops out to me is that I have a triangle right here, triangle ABC, this big triangle, and that means that what I can do is I can solve for this angle right here that's missing. 82 plus 26 subtracted from 180 will get me that angle. 82 plus 26 is 108. 180 minus 108 is 72. So this angle right here is 72 degrees. Okay, next, they're not explicit about this, but the giveaway is this DE divides AB and BC proportionally. And what's the giveaway? That DE is parallel to BC. So therefore, knowing that angle B is 72, this angle here is also 72. This angle is equal to angle B because they are corresponding angles because of the parallel lines. So if that's 72, that's 72, we can figure out what each of these two angles measure. This 72 plus these two angles, which I don't know their measurement, I'm just going to go ahead and call them X. That 2X plus 72, they must add up to 180. What's 180 take away 72? So let me just go ahead and zoom out here. So 180 take away 72 is 108. Dividing by 2, we will get X equals 54. So this is 54, right? This angle here, and this is also 54. So now I can solve for the angle they want. This is the one they want. So 54 plus 72 is what? So 54 plus 72 is 126. 180 take away 126 is 54 degrees. That's my final answer. Okay, so number 11, which set of statements would describe a parallelogram that can always be classified as a rhombus? If you know your properties, these are the properties here. This was not given on the test. I just added that here. You know that in a rhombus, the diagonals are perpendicular and the diagonals bisect the angles. So we know that option 1 and option 2 are viable ways to describe a parallelogram that can always be classified as a rhombus. Option 3 says the diagonals form 4 congruent isosceles right triangles. So let's go ahead and work that out. All right, so here I drew a parallelogram, I drew the diagonals, and option 3 is telling me that we're going to have 4 congruent isosceles right triangles. So what that means is that all these sides are equal, and you have right angles here. And so all these triangles are isosceles and they are congruent to each other. Now, if that's the case, if all these triangles are isosceles and congruent to each other, then we can actually now assume that this side is equal to this side, and then all those sides are congruent. And if all the sides are congruent, then it would be a rhombus. So it's actually 1, 2, and 3. So the answer for number 11 is option 4. All right, so here is number 12. We are slowly working our way through this region. It says the equation of a circle is x squared plus y squared minus 12y plus 20 equals 0. What are the coordinates of the center and the length of the radius of the circle? So we got to use the completing the square method to put this in standard form. So we're going to write x squared plus y squared minus 12y plus a box equals negative 20. If you want to know more about this method, you could check out my video on completing the square to put a circle equation in standard form. So what goes in a box? Inside the box, we do b divided by 2 squared. So that means let's take this negative 12 divided by 2 and square it. If we do that, we will get 36. So we add 36 on this side and we add 36 on this side. So we get x squared plus y minus 6 squared equals 16. So I got this by factoring this trinomial here. You see this trinomial? So if you factor that trinomial, you get y minus 6 times y minus 6, which you can rewrite as y minus 6 squared. So the center is 0, comma, positive 6, because we need to change the sign of negative 6. And the radius is the square root of 16, and that's 4. So we get 0, comma 6, and the radius is 4. So the answer is choice 1.